Hi students, this is Mr. Yao. In the last lesson, we have defined the important information or features of ellipse. In this lesson, we're going to continue to learn more about that. Last lesson, we have ellipse centered around the origin. This lesson, of course, we're going to move them around. But before that, let's actually review something we have learned before about equation of circles. We're going to rewrite this equation in standard form. In order to do that, the first thing we need to do is to move all the x and the y's on the left side so that we can complete the square. 4x squared minus 24x, let's leave a space for that, plus 4y squared minus, plus 32y, leave a space. We're going to need to move the 4 to the other side. So after that, you may notice, we currently have not just x squared and y squared, they both actually have 4 in front of them. So we're going to divide everything by 4 before we complete the squares. We will get now x squared minus 6x, then space, plus y squared plus 8y, then space, which equals to 1. For the x, negative 6 divided by 2 is negative 3, square that, that's going to be 9. We're also going to do that on the right side. For the y, 8 divided by 2 is a 4, 4 squared, that's going to be a plus 16. We are also going to do that on the right side. Now we can actually write it, x minus 3 squared plus y plus 4 squared equals to, that's 10 plus 16, which is 26. Now to go a bit further, the center will be 3, negative 4, and the radius will be square root of 26. We are going to do something very similar in this lesson to be able to find the equations of ellipse. But before that, let's actually talk about the ellipse that are not centered around the origin. The general equation for ellipse, instead of just having x squared over a squared and y squared over b squared, in fact, we can actually move it around anywhere in the graph, in the coordinate system. Then we'll actually have the minus h for the x and minus k for the y again. And of course, since we have two different ways of generating the ellipse, you're going to have the major axis either on the x or on the y. So the a squared, the bigger square, may actually be under x or under y based on where the major axis is. And the center would be h comma k, just like how the circle works. Example 1. Identify the features and a graph. First, you do need to understand this one does have an over 1, and in this case, I can identify the center. Remember, it's always going to be the opposite numbers of what's given inside the parentheses. So the center is actually going to be a negative 2, comma positive 1. Major axis, that's where we need to look at the squares in the denominator. Whichever one is bigger, that letter, that variable will be the major axis. In this case, the major axis will be 1 because 25 is clearly bigger than 1. Now we can go for our A. As soon as we have identified that the major axis, the 25, A would have to be square root of that, which is 5. Then the smaller denominator 1 would have to be b squared, so b is 1. As for C, let's not forget, in an ellipse, we have that triangle. This portion is your C, that's your B, and this is your A. So C squared equals A squared minus B squared, which in this case, 25 minus 1, it is 24. And I will keep them as radicals. So C would have to be 2 square root, 4 square root, 2 square root of 6. There we go. The minor axis length, minor axis referring to B, and the length would have to be 2b because you have the top portion and the bottom portion. That means it would have to be 2. Vertices. Vertices will be the one on the major axis. Our major axis is the y, so we're going to use A and write that as the y coordinate. We will have 0, 5. Actually, take it back. It is not going to be 0 anymore because we do have the center not at the origin anymore. So let's start drawing. So negative 2, 1. That's where the center is. And the major axis is on the y direction, so it's vertically. And A is 5. That means the vertices are both 5 away from the center. So from here, count up 5 and go down 5. That's where we have our actual vertices. They will be negative 2, 6, and negative 2, negative 4. So you see the length doesn't change. Between 6 and -4, the length is still 10. Co-vertices, well, this time we're going to use B, and we are going to count left and right by 1. Left 1, right 1. So that means it will be -3, 1, and -1, 1. As for the foci, foci is 2 square root of 6 from the center. My center currently is at -2, 1, but don't forget, the foci would actually be on the major axis. So that means it's going to be 2 square root of 6 above 1 or 2 square root of 6 below 1. So it will be quite close to our major axis vertices. So -2, 1 plus 2 square root of 6, or -2, 1 minus 2 square root of 6. So that's where things started changing. You got to put down the center first. That's why having a graph is always going to be helpful. Now I can actually complete my ellipse. It's a very narrow ellipse again. That is example 1. Moving on, example 2. Similar things, but before we start, we got to make sure the right side is a 1, since this is currently not even a standard form of the ellipse equation. So we're going to divide both sides by 36. We'll always do that because we just want the right side to be a 1. As for the numbers in front of the x and the y, well, they will always be simplified into some kind of fraction. So 9 over 36, 4 over 36. That becomes x minus 1 squared over 9, actually 4. And plus y plus 3 squared over 9, that equals to 1. My center, 1, -3. Major axis, well, the bigger number is under y again. That means y has to be my major axis. And because that is 9, so my a would have to be 3, my b would have to be 4. As for c, c squared equals a squared minus b squared, which is 9 minus 4, that is 5. So my c would have to be square root of 5. Minor axis length, again, that is always going to be 2b. In this case, b is 4, so that means it's going to be 8. After you have identified these things that are not quite related to the center, when you want to identify vertices, co-vertices, and foci, again, draw this graph. Put down the center so you can actually start counting from the center. 1, -3. A is 3, and they are vertically. Oh, actually, I wrote down the b wrong. B is the square root of 4, which is actually a2. So the minor axis length would actually be 4. So again, going back, major axis is y, so it's going vertically, and a is 3, that means we're going up or down by 3. So that is our major axis. As for the minor axis, we will have left and right, so this time counting 2 to the left and 2 to the right. I can now write down my points. My vertices would actually be 1, 0, or 1, -6. As for my co-vertices, they would be -1, -3, or 3, -3. Foci, again, foci is c away from the center on the major axis. So it's going to be from this point, count square root of 5, which is slightly over 2. Slightly over 2. So there's my ellipse. Doesn't quite look the best, but it's the ellipse. And foci, the x does not change. It's going to be a 1. And then the y coordinates will be square root of 5 away from that -3. So it's going to be -3 plus square root of 5, or -3 minus square root of 5. That is example 2. Moving on, example 3. Based on the information or graph, write the standard form of the equation. You are given the vertices and you are given the foci, and it's asking you to write down the actual standard equation. What's a bit harder in here is because our center is not around the origin anymore, so we do actually need to identify the center. But remember, the center is always going to be in between the foci or in between the vertices. So we're finding the midpoints. The center would be 0 plus 6, divided by 2, and negative 4 plus negative 4 divided by 2, which would be 3, negative 4. As you may notice, these vertices, they all have the same y value. Same y value means they're the same height, so that means my vertices would actually be horizontal, and my A, so this is where you're going to need to know the distance between the two vertices. The two vertices are 6 away, and 6 would have to be at 2A, so my A will be a 3. And as soon as we know that, we can also look at the foci. The foci are, well, 1 and 5, because they all have the same y coordinates. That means they're all staying on the same horizontal height. So they're all going to be on the horizontal major axis. And now, between 1 and 5, we have 4 away. That means my C would have to be a 2. So for this one, I'm just talking through these information, but a good thing that you can always do is to draw a graph. So in example 4, I will actually show you a graph, but in here, just kind of imagine trying to think through these information. So let's kind of think it again. 0, negative 4, and 6, negative 4, they're the vertices, and foci would actually be on them. That's where you can find the C and the A. And the B squared would actually be A squared minus C squared. So it's going to be 9 minus 4, which means 5. So now I can write down my equation. It's going to be x squared, because my major axis is actually horizontal. So it's going to be x, well, not x squared, sorry, x minus 3 squared, since that's where my center is. That is going to be over 9, because it's a squared, plus y plus 4 squared all over my b squared is 5, and that equals 1. That's example 3. Moving on, example 4. Let's think about these points. 3, negative 7, and 3, 3. Let's say 3, negative 7, let's say this is 3, negative 7. So 3, 3 would actually be just above. And a quick thing that you can sketch is you don't have to draw the whole ellipse, but at least try to label them so you can identify clearly which direction would be your major axis, so you can actually label the A, the B, the C. So in this case, I have 3, negative 7, and 3, 3. They are 10 away from each other, which means my A would have to be 5, and it's on the y direction because it's a vertical major axis. And because of that, I can also calculate my center. My center would have to be, of course, the horizontal, well, of course, the x coordinate would have to be 3, but then it's going to be in between 3 and negative 7, so 3 plus negative 7 divided by 2. My center would have to be 3, comma, negative 2. That's where 3, comma, negative 2 is. Next, I can also draw on that major axis where my foci would be. 3, negative 6, and 3, 2. And since my center is 3, negative 2, again, always use the vertices to find your center first, and then you can identify the foci based on that. So 3, negative 6 is 4 away from 3, negative 2. That means my C would have to be 4. Then as soon as we have the A and the C, we can calculate the B. B squared is A squared minus C squared. So 25 minus 16, that is going to be 9. And since that is on my y-axis, I can actually start writing my equation. X squared is actually going to be over 9, but y squared is going to be 20 over 25 in this case. And I also need to incorporate the center into the x squared and the y squared part. It's x minus 3 squared, and then y plus 2 squared. There's example 4. Moving on. Example 5 and 6. So this time we have these equations that are different from the circle equation, if you haven't noticed, because the number in front of your x squared and y squared are in this case different. But no matter what, we do still want to move them to the left side of the equation. So let's do that. First, we will have 16x squared on the left plus 49y squared plus 98y, and then a space, which equals to negative 33. Here's what's a bit tricky. Because as of right now, we don't exactly know what's going into the space because we have a 49 in front of the y. So something you got to be careful. When you try to complete the square here, it's going to be a little bit different. We're going to try to ignore that 49. Because of the x part, we do not need to deal with anything like that. So we're just going to keep that 16x squared. But for the y, we're actually going to factor out a 49, since this could also be divisible by 49, so that we're only left with a y squared inside the parentheses. We'll be left with y squared plus 2y. Now we have a space. We can figure out that space very easily. 2 over 1, which is a 1, then square it, we'll have a plus 1. But something to be careful. Remember, this one is inside the parentheses. You still have the 49 on the outside the parentheses to actually multiply with everything. So in fact, on the right side, when we try to balance the equation, it's not just a plus 1. It's actually a plus 49. So now let's rewrite it. We have 16x squared, that stays, plus 49 of y plus 1 squared, and that equals to 16. Our goal is for the right side to actually be a 1. So we just need to divide everything. Let's divide everything by 16. We will have x squared plus y plus 1 squared, but this is multiplied by 49 over 16, which is the same as divided by 16 over 49. On the right side, that is 1. So this is quite a tricky question. Now let's start identifying things. The center would be 0, negative 1. These are the numbers that are related to the x squared and the y squared. And we can also start identifying our a, b, and c. 16 over 49 is clearly smaller than 1, so our a would have to be 1, but our b would have to be 4 over 9. However, remember, a represents the distance from the center. So let's actually draw a center. We know the major axis is going to be x. So let's say this is our 0, negative 1. That's where the center is. Again, this is not my x-axis. That is actually my major axis. So let's say this is 0, negative 1. It's 1 away, so it has to be on the positive side a 1, negative 1. And on the negative side, a negative 1, negative 1. These will be my vertices. Negative 1, and 1, negative 1. Again, they are 1 away, but it's horizontally away from that 0, negative 1. Length of minor axis, which again is 2b. Since my b is 4 over 7, I just need to multiply that by 2, which is 8 over 7. That is example 5. Next, example 6 is something very similar. So let's go ahead, try to figure it out. First, let's put all the x together. 9x squared minus 108x. And then we have 25y squared plus 250y. On the right side, we have negative 885. So first, for all the x's, we are going to take out that 9 in the front. So we are left with x squared minus 12x, leaving a space. For the y, we're going to take out that 25. So we're left with y squared plus 10y with a space. On the right side, we currently just have negative 885. Now we need to start balancing it. Negative 12 divided by 2 is 6. Put in there, 36. Remember, on the right side, we need to actually include that 9 in the front again. So it's actually 9 times 36. That's what we're actually adding. So let's add it. Plus 9 times 36. That would actually give you 324. Then for the y's, 10 over 2 is a 5. Square that is plus 25. But again, it's 25 times 25, so we're actually adding 625. Now we can actually start putting things together. 9 inside the parenthesis would be a negative 6, so it's x minus 6 squared plus 25. Then it's going to be y plus 5 squared. That would actually equal to 64. Now, in order for the right side to be a 1, we're going to divide everything by 64. This is always where things get more complicated, because these fractions will actually need to go to the bottom of a fraction, so we need to flip them. To rewrite it, x minus 6 squared all over 64 over 9 plus y plus 5 squared all over 64 over 25. That equals to 1. 64 over 25 is clearly smaller than 64 over 9. So this would have to be my a squared. That would have to be my b squared. Let's start with the center. My center is going to be 6, negative 5. My a squared is 64 over 9. My b squared is 64 over 25. I can actually find my c squared. C squared would be a squared minus b squared. And that would give us 64 divided by 9 minus 64 divided by 25. If I want to change that into a fraction, that is going to be 1024 over 225, which means my C would have to be 32 over 15. The foci, well, we can identify that the A is actually on the x-axis. Our foci would be 32 over 15 away from the center, x-axis. So it's going to be 6 plus or minus 32 over 15, comma, negative 5. And of course, you can choose to calculate them out separately. And that is example 6. Now that we have learned about circles and ellipse, we can actually explore a bit more why they are called conics. It comes from the word cone. And here they are. Depending on how we're cutting through a cone, we may have different curves. If you're cutting horizontal parallel to the base, you're going to get a circle. Even if you tilt it a tiny bit, that's going to give you an ellipse. If you tilt it more and just cut through one of the cone, when you have two of them next to on top of each other, like the pointy, they share that point. If you cut it parallel to the side line, you are going to get a parabola. And lastly, if you cut it perpendicular to the base, or if you just cut through both of them, two cones at the same time, you are going to get something called a hyperbola. And in the next lesson, we will learn hyperbola. And in the very last lesson in this unit, we are going to learn about parabola. And that is everything for this 8.1b lesson. Thank you.